Hello, Assalamu alaikum. Today I am going to solve MCQs of first chapter of AS Physics, Physical Quantities and Units. So the first topic, subtopics is base and derived quantities. And I am solving my own topical booklet. So hope this will help you. So the question one is, this is the coding of questions. This is question number and of the year, and this is the year of the year in which this question appeared, May, June. This is the session, and this is year, and this is variant of the question, variant of the paper. So you can track this question if you find any difficulty. So the first question is, which is a pair of SI based units? So in this case, if you look option A, ampere is SI base unit, but joule is not SI base units. Coulomb is not SI base units, but second is SI base units. And kilogram and Kelvin both are SI base units. Okay, so C is the right answer for this. Question 2 is, which row shows an SI base quantity with its correct unit? So we have to look for SI base quantity. Charge is not base quantity, so we will not consider this option. Electric current is SI base quantity, and its unit is ampere, which is correct option. If we look at the C, potential difference is not SI base quantity, and temperature is SI base quantity, but the degree Celsius is not SI base unit. Question 3 is, which is an SI base unit? Current is base quantity, not unit. We have to look for SI base unit. B, gram is unit, but not SI base unit. Kelvin is SI base unit. Volt is not SI base unit. Which row shows a base quantity with its correct SI unit? So question 4, current is base quantity, and its unit is ampere. So symbol is A. So option A is correct for question 4. If we look at the second option, mass is SI base quantity, but its unit is not gram. Temperature is SI base quantity, but its unit is not degree centigrade. Weight is not SI base quantity. Which pair of units are both SI base units? So we have to look for SI base units. Ampere is SI base units. Degree Celsius is not SI base units. Ampere is SI base unit. Kelvin is SI base unit. So these two are SI base units. So over here, Coulomb is not SI base unit. Degree Celsius is not SI base unit. D option is Coulomb is not SI base unit, but Kelvin is SI base unit. What is the unit of resistance when expressed in SI base units? So we have to work for unit of resistance, and you know that according to Ohm law, V is equal to IR, and this is the equation from which resistance is defined. So resistance is V over I, and you know that V is potential difference, and that is defined as work done per unit charge, and work done is F times D, and F is mass time acceleration time displacement. So unit of work done is kg, acceleration is meter per second square times meter. So unit of SI base unit of work is kg meter square S minus 2. This is SI base unit of work. So what is SI base unit of potential difference? That is, work is kg m square s minus 2 divided by this q is charge, and you know that I is charge over time. So unit of charge in terms of charge is not base quantity. I is base quantity, time is base quantity. So unit of charge will be I times T, which is ampere second. So unit of Q is ampere second. This is unit of V. So what we have to do, we should first simplify this. That is kg m square. You have to use the rules of indices, s minus 2, and this is in denominator there is s1. So this will go up. That will make it s minus 3. That is minus 2 minus 1. And a in denominator, this is positive 1. So when a will go in the numerator, it will become a minus 1. So this is unit of potential difference. And for SI base unit of resistance, we have to put this unit over here. So that is kg m square s minus 3 a minus 1 divided by the unit of current is a ampere. So you have to simplify it. That is kg m square s minus 3. This in numerator a power minus 1. This 1 will go up, and when you have same bases and the quantities are divided, then you subtract their powers, minus 1 and this minus 1, that will become minus 2. So unit of resistance is kg m square s minus 3 a minus 2. So for this kg m square s minus 3 a minus 2. This is a little difficult question, but you have to do the all calculations. So that is kg m square s minus 3 a minus 2. Question 7, which list contains only SI base units? We have to look for SI base units. Ampere is SI base unit. Kelvin is SI base unit, but gram and joule are not SI base units. Kilogram, Newton is not SI base unit. Meter is base unit. Ampere is base unit. Meter, coulomb, second, Kelvin. Coulomb is not SI base unit. So, what is the right choice? Second, Kelvin, ampere, kilogram, all these are SI base units. So, D is correct option for this question. Which of the following definitions is correct and uses only quantities rather than units? So, density is mass per cubic meter. Mass is quantity, density is quantity, cubic meter is unit. So we have to look for quantities rather than units. So this is unit, so A is incorrect. Potential difference is energy per unit current. So potential difference is quantity, energy is quantity, and per unit current. This is incorrect formula. You know that potential difference is energy over charge. So this formula is incorrect, and you can even reject this choice because potential difference is quantity, energy is quantity, current is quantity. All these three are quantities, but the formula is incorrect. Pressure is force per unit area. Pressure is quantity, force is quantity, area is quantity, and this formula is also correct because pressure is defined as force per unit area. So question 8, C is correct option. For question 9, when a beam of light is incident on a surface, it delivers energy to the surface. The intensity of the beam is defined as energy delivered per unit area per unit time. So this is the definition of intensity, that is energy per unit area, and then whole per unit time mean whole divided by time. So that is, let me use symbol E for energy, A for area divided by T, that will become energy over area, and this, if I convert this division into multiplication, that will be 1 by T, so T will be here. So this is the formula according to definition, and you know that the unit of this energy is for unit of energy you can use the definition of work done, because work and energy, work is also the form of energy. When you do work, the energy of the object changes. So work and energy have same units. So work is F into D, that is kg. F is m times A. M is kg, and A is meter per second square times D is meter. This is unit of work, that is kg m square s minus 2. I have already done that unit. So for intensity, put this unit over here, that is kg m square s minus 2 divided by area. Unit of area is meter square and unit of time is second. So that will become, meter square will cancel out. Meter square will cancel out. So that will be kg s, this is minus 2 and this will go up, that will become minus 3. So unit of intensity is kg s minus 3. So the D is right answer. Which of the following could be measured in the same units as force? So what is unit of force? Force is mass times acceleration, that is kg ms minus 2. So this is unit of force, SI base unit. Energy over distance. Let us simplify this option. Energy is work done per unit work done, and work done is kg meter square s minus 2 divided by distance, that is meter. So that is kg ms minus 2. So energy over distance will give you same unit as the unit of force, that is kg ms minus 2. Energy into distance will not give you this unit. So the first option is correct. We do not need to simplify all other options. The momentum of an object of mass m is p, which quantity has the same basic units as p over m. You know that momentum is defined as product of mass and velocity, and if you divide this momentum by mass, that is mass times velocity is the formula of momentum divided by mass. So you will be left with only velocity. So when you divide momentum with mass, you will get velocity, and velocity will be the right answer for this option. The unit of work the joule may be defined as work done when the point of application of force of 1 Newton is moved a distance of 1 meter in the direction of force. Express joule in terms of base units of mass, length, and time. You know that joule is the unit of work, and we know the formula of work is F into D, that I have already done, and F is mass time acceleration time D, so that is kg. Acceleration is meter per second square, time displacement is meter, so that is kg m square s minus 2. So this is unit of work is joule, and joule in terms of SI base unit is kg m square s minus 2. So 12, answer B is correct. What is the unit of stress? You know that stress is defined as force per unit area. This is stress, and in given options, there are some base units and some derived units as Newton per meter, Newton meter. If you first think that if you use force, unit of force, if you use Newton and unit of area as meter square, so that will be Newton per meter square. So the two derived units are not correct. So what you have to do, you have to work, you have to put SI base unit of Newton. So that is, you already know that is mass time acceleration. So it is kg ms minus 2 divided by meter square. So that is kg m minus 1. This is 1, and this will go up. That is 1 minus 2. So that will make it minus 1 s minus 2. So this is kg m minus 1 s minus 2. So 13, option A is correct. So what is the best way of describing a physical quantity? So this is a quantity with magnitude and a direction, but no unit. No, a physical quantity should have unit. Without unit, we cannot describe a physical quantity. For example, if I write a mass of any object is 5, and I don't put the unit over there, then it will be meaningless. So be a quantity with magnitude and unit. So this defines, this is the best way of describing a physical quantity. It should have magnitude and should have unit. For example, mass of 5 kilogram. 5 is magnitude and this kg is unit. There are few quantities which need direction as well. They are known as vectors. So C, let's check C, a quantity with magnitude but no direction. Over here, we do not discuss magnitude. A quantity with magnitude, but there must be a direction. There must be unit as well. So without unit, there is not the best way of describing a physical quantity. A quantity with a unit but no magnitude, no. If you say my mass is this much kg, and you don't put magnitude, so this is not the best way of describing a physical quantity. Which SI unit expressed in base units is not correct? So be careful about this not. Now we have to look for the option which is not correct, okay? Unit of force is kg ms minus 2, this is correct, okay? Unit of momentum is defined as mass time velocity, and mass is kg m minus 2, this is correct. Unit of pressure is defined as force over area, and force is mass time acceleration, that is kg ms minus 2 over meter square, that is area. So this is kg m minus 1 s minus 2. So this is not incorrect unit of pressure because there should be minus 1. Unit of work, I have already done that, kg m square s minus 2. So these are correct units, and we have to work for the units. which are which is not correct. So most of the students forget this not and they just pick option A, that they see that unit of force is kg meter per second square and they go for it. But you have to be very careful about these words. For example, not. Which pair of units are not the same when expressed in SI based units? So ms minus 2, this is SI base unit, and we have to put N is for Newton. So for A, we have to put this Newton in terms of base unit, and we have to look whether this is equal to this. So Newton is force, and force is mass times acceleration, that is kg ms minus 2 times kg minus 1. This is kg, and this is I have put Newton in terms of base unit. So this power kg, we will simplify this kg, and if we simplify this kg power 1 and minus 1, we will add these powers. So kg 1 minus 1 ms minus 2. So that is kg power 0. Anything power 0 is you know that this is 1, so this is ms minus 2. So Newton per kg is same as ms minus 2. So option A is correct for this. So which pair of units are not same? Okay, again we have to look for this not. So they are same. So we will not take this. Newton second and kg meter per second. So let's simplify B and put this Newton as in terms of SI base unit, that is kg ms minus 2 times s, that is kg ms, this is minus 2 plus 1, that is minus 1. So kg ms minus 1, that is same as this. So they are also same. Okay, these two are same. We have to look for the option which is not same. C is, this is the unit of pressure, that is Pascal, and this is Newton per meter square. You know that pressure is force over area, and force is Newton per meter square, and the unit of pressure is Pascal. So if you put this Newton in terms of SI base unit, and you simplify this Pascal, you will have same unit, because pressure is force over area and force is Newton per meter square, and these two are of same units of same physical quantity. So this is also incorrect, and obviously we will directly pick the options, because we don't need to simplify this, because all other three options are incorrect. So these two are obviously don't have the same when we express this in terms of SI base units, but you can verify that this is Newton per coulomb, this is volt per meter square. If you put you have to put coulomb in terms of SI base unit, Newton in terms of base units, and volt in terms of base units, and then you can compare. They are not equal. Okay, so what correctly expresses the volt in terms of SI base units? I have done this. You can see the previous option, but if, it's better that I simplify this over here. We have to look for SI base units. Ampere is not SI base unit, and this ohm is not SI base units. Watt is not base unit, SI base unit. So these two are obviously incorrect. And then C, we have to work for C and D, and we have to use this formula. You know that potential difference is defined as work done per unit charge. And you know that work done is kg force time distance. That is, if you simplify this, that becomes kg meter square per second square divided by coulomb is ampere second. So that is kg m square, and that you have to simplify this s, that becomes s minus 3 and a minus 1. That is kg meter square s minus 3 a minus 1. So for 17, D is your right answer. What is the unit of weight in terms of SI base units? So weight is, you know that weight is force and force due to gravity, and you know that unit of force is mass time acceleration. We have done that. So that is kg ms minus 2. So this B is right answer. And unit of weight is also Newton, but we have to work for base unit. So don't pick this C. Three of these quantities have same units. Which quantities has different units? So we have to work for different, the quantity which have different unit. Energy over distance. You know that energy is defined as work done. Sorry, you know that force time distance is energy, and if you divide energy by this distance, you will get force. So this is unit of force, and force B is also in force, and power time. You know that power is defined as work done per unit time, and if you multiply power time, you will get work. Okay, so power into time will give you unit of energy, and rate of change of momentum. You know that according to Newton's second law, rate of change of momentum is equal to net force. So this is also equal to force. This is also force. This is also force. So C, all these three have same unit, but C1 has different unit. So 20th, which pair of quantities do not have the same SI base units? Electromotive force and electric potential difference. You know that potential difference is unit of potential difference. Potential difference is defined as work done per unit charge, or energy transferred per unit charge, when energy is converted from electrical to other form. And electromotive force is also defined as energy per unit charge when energy is transferred from other form to electrical. So these two have same SI base units. We have to work for those who do not have the same base units. So A is not our option. Pressure and stress. Pressure is force over area, and stress is also defined as force over area. So they have same SI base units, spring constant and moment of force. And you know that according to Hooke's law, F is equal to K times X. You have already done this in your O level, that if you apply some force on the spring and X is the extension, so extension is directly proportional to this force, where this K is spring constant. So for unit of spring constant, you will make it subject. So that is Newton per meter, and moment of force is defined as product of force multiplied by shortest distance from the pivot to the line of action of force, that is F times D, that is Newton meter. Okay, so if you simplify this, so this is Newton meter, this is Newton per meter. So if you simplify them and convert them into SI base unit, they will not have the same SI base units. So C is our choice. Torque and work is F into D. Torque is F into D, so they have same base unit. 21 is which quantity with its unit is correct? Acceleration of bicycle is 1.4 meter per second. This is not the unit of acceleration. That is, acceleration is meter per second square. Electric current in lamp, electric unit of electric current is ampere. This is not ampere per second. Electric potential difference is 8 joule per coulomb. You know that potential difference is work done per unit charge. So we don't need to simplify them in convert them in SI base units. So unit of work is joule and unit of charge is coulomb. So unit of electric potential difference have unit joule per coulomb. Okay. So C is correct option. Kinetic energy is not Newton per meter. You know that energy is Newton into meter, that is F into D. So C is our correct option. In the expressions below, A is acceleration, F is force, M is mass, T is time, V is velocity. Which expression represents energy? So you know that energy is force time distance. So force time is not energy. Force time velocity into t. You know that velocity time t is displacement. So force time displacement is energy. There are two options, two ways. You can simplify. You can put units of each expression and simplify. Uh, if you get the unit of energy, you have to pick that expression. Or in other words, you can work in quantities as well. Over here, this is momentum m into v, and if you want to simplify this, that is kg m s minus 1 over second, that is kg m s minus 2. So this is not unit of energy. Unit of energy is, you know, that kg m square s minus 2. And even if you want to simplify this, D option, that is unit of acceleration is meter per second square times unit of time, that is second square. So this is m. So this expression have unit of displacement. So we have to work for unit of energy. So B is correct option for this. What is the unit of Young modulus when expressed in SI base units? You know that Young modulus is defined as ratio of stress over strain, and stress is force per unit area, and strain is change in length, that is delta L over original length. When you apply some force on any material, any wire, the length, if length of wire changes, so strain is defined as change in length. This is original length L, and let's say this is change in length delta L. So strain is defined as change in length over original length. So strain has no unit because change in length is also measured in meter, and length is also measured in meter. So this has no unit. So this is Newton that we have to work for SI base unit. So kg m meter per second square over this meter square. This term has no unit. No need to simplify this because meter over meter will cancel out. So that is kg m s minus 2 divided by meter square. So you will get kg m, this is 1, this will go up, that will make it 1 minus 2, that is minus 1, s minus 2. So kg m minus 1 s minus 2. So A is correct answer. Which definition is correct and uses only quantities rather than units? Density is mass. You know that density is mass per unit volume. So density is quantity, mass is quantity per cubic meter. This is unit of volume, but this is unit, not quantity. So we have to work for expression which have only quantities. So A is incorrect. Potential difference is energy per unit current. You know that this is potential difference is energy per unit charge. Okay, so although this expression uses all physical quantities, but definition is incorrect. Pressure is force per unit area. So C is correct option. Pressure is defined as force per unit area, and all these three are quantities. Area is quantity, force is quantity, pressure is quantity. Speed is distance traveled per second. Speed is, you know that distance travel per unit time. So uh, this second is unit. Okay. So C is correct option. Which statement includes a correct unit? Energy. Energy is Newton F into D, that is Newton meter. So this is incorrect. Force is Newton second. Force is Newton, not Newton second. Momentum is defined as you know that product of mass and velocity. And if I simplify this Newton, that is kg ms minus 2 times s. So that is kg ms minus 1, and you know that this is also kg ms minus 1. So 25th C is correct option. What is the joule in terms of SI base units? And you know that joule is the unit of work done, that is force into D, unit of energy, that is kg ms minus 2 times meter, that is kg meter square s minus 2. What is equivalent to unit of electric field strength? Electric field strength is defined as force per unit charge. Force per unit charge. And first you have to look for the options. In few options there are base units, and even you have some derived units like joule, coulomb, Newton. So if you first you put uh, derived units, that is Newton per coulomb, charge is coulomb, so Newton per coulomb. This is the derived units of electric field strength. And you know that coulomb is Q is defined as current is defined as Q by T. So coulomb is I into T, that is ampere second. So if I put this as ampere second, that is Newton, coulomb is A S minus 1. So this is Newton A minus 1 S minus 1. So we have to, so that's why this is incorrect. So what I have to do, I have to put SI base units of Newton, that is kg ms minus 2 times A minus 1 S minus 1. So what we have to simplify this, that is kg s minus 2 minus 1, that becomes s minus 3 and A minus 1. So kg s minus 3 A minus 1. So 27 C is correct answer. Which pair of units contains one derived unit and one SI base unit? Ampere is SI base, coulomb is derived. Okay, so 28 A is correct option. Kilogram is base, Kelvin is base, meter is base, second is base, Newton is derived, Pascal is derived. So these two have derived units, two base units, one base and one derived. Okay, so let me do this question as well. What is the unit of resistance? We have already discussed this, so I will not do that because you know that V is IR and resistance is V over I. So put unit of formula for voltage, that is for voltage, energy over charge, and then put unit of current. So what is the unit of stress? This is also repeated question. Stress is force per unit area, and force is kg ms minus 2 over meter square, that is kg m minus 1 s minus 2. kg m minus 1 s minus 2. So A is correct option, 30th A. Okay. The equation relating pressure and density is P is rho gh. How can both sides of the equation be written in terms of base units? So you have to put SI base units of pressure, that is pressure is force over area. So force is kg m s minus 2 divided by meter square, area that is kg m, this goes up, minus 1 s minus 2, kg m minus 1 s minus 2. So this side is correct for pressure. Okay, so you can simply reject this because this is not using base unit, this is not using base unit. C and D have only base units. So what the unit of pressure is kgm minus 1 s minus 2, and D is kgm minus 1 s minus 1. So C is correct. This density is mass per unit volume, that is kg per meter cube. This G is gravitational acceleration, that is meter per second square, and this height is meter. So C is correct option. Which unit is equivalent to Coulomb? You know that current is defined as charge per unit time, and you should think that this Coulomb is unit of charge. Okay, so charge is basically charge is current time t, that is ampere second. So ampere second is ampere per second is not charge. Okay, so A is incorrect. Joule per volt. Okay, joule per volt. You know that volt is defined as energy per unit charge. So that is unit of energy is joule per unit charge. Unit of charge is coulomb. So coulomb is if you make this C as subject, then it will be joule per unit volt. So that's why joule per volt uh, is equivalent to coulomb. Watt per ampere, watt is power, per ampere is current. So this is not equivalent to coulomb. This is very good question. The unit of resistivity expressed in terms of base units is given by this. Which base units are X, Y, and Z? So you have to work and you have to simplify the unit of resistivity, and then you can answer this question, otherwise not. So you know that the expression for resistance is rho L over A. You know that resistance of a wire is directly proportional to its length and inversely proportional to its cross-sectional area, and this is resistivity. Okay, so we have to make this as subject of formula, that is this will be this A will go here, or A over L. This is equivalent, this is equal to resistivity. And for resistance, you know that V is IR and resistance is, that is V over I. This is again, I am repeating it. And volt is defined as energy per unit charge, that is kg meter square per second square over charge is ampere second. Okay, so this is what is defined, energy per unit charge And if you simplify this, kg m square s minus 3, that will go up, and a minus 1. This is the unit of volt, potential difference, and potential difference over current will be equal to unit of resistance, that is kg m square s minus 3 a minus 1 over ampere. This goes up, that is kg m square s minus 3 a minus 2. This is unit of resistance. So that is kg m square s minus 3 a minus 2. I'm sorry, time this is area, that is meter square over meter. Okay, so this is unit of resistivity. Let's simplify this. Kg m square m power 4 divided by this m1, that becomes m3 s minus 3 a minus 2. Okay, so let's look at this option, that is kg. What is x? If you compare these two expressions, so the power of m is positive 3, and over here x is 3. So x is kg, x is kg, and sorry, x is meter, and this y power minus 2 over here, a power minus 2, so y is ampere. This is very good question. And s minus 3 over z minus 3, so z is second. So which option is correct? So 33, if you compare this, so you will be having b, x is meter, y is ampere, and z is second. So it's a very, very good question. You have to simplify, you have to work for unit of resistivity, and you should know this formula for resistivity, from which this resistivity is defined. You have done this in your O-level class. So then you have to put unit of resistance, length, and ampere, area, and you have to compare these two expressions. What is the unit of power? This is a very simple question. You have already done that. Power is defined as work over time. Rate of work doing, the rate of energy transfer is known as power, and power is work done is kg meter square s minus 2. We are doing it many times, so this time is second. So if you simplify this, kg m square and s minus 3, kg m square s minus 3, so 34 a is correct option. 35. Which quantity has the same base units as momentum? You know that momentum is mass times velocity, that is kg ms minus 1. So density time energy, density is mass per unit volume time uh, energy is basically F into D. So if you put unit of this, so mass per unit volume, that is kg over meter cube times F is MA, kg meter per second square times meter. So that is kg square m power 2, and this will go up, that will make it m minus 1 and s minus 2. So this is not equivalent to this, so we will reject this A. 35 A is incorrect. Density, volume, and velocity. Density is, you know that mass density is mass over volume time velocity. So this volume will cancel out. So mass time velocity is momentum. So B is correct option. 36. We have to work for how many questions more? So let's work for question 36. The units of all physical quantities can be expressed in terms of SI base units. Which pair contains quantities with the same base units? Force and momentum. They do not have same base units because force is mass time velocity, mass time acceleration, and momentum is mass time velocity. Pressure and Young modulus, they have same pressure is force over area, and Young modulus also have the same units. So B is correct option. 36. B is the answer. 37. The SI unit of potential difference is given. So we have already done that. Potential difference is defined as work done per unit charge. So work is F into D, time charge is ampere second. So put unit of force and displacement, you will get answer. What is the possible unit of product VI, where V is potential difference across a resistor and I is current through the resistor? So we have to work for the unit of VI and Newton per second. All units are mixture of derived and base units. So let's simplify this. VI and V is defined as work done per unit charge Q times I. Okay. So work is F into D and this I over Q. You know that I is Q by T. So this I is, if you put this Q is I into T, you will just simplify this I, and this Q is I times T. This will be cancel out. So force into distance divided. So force has unit Newton, distance meter, this time second. So this is Newton, ms minus 1. So D is correct option for 38. 39. What is the unit of watt? Unit watt in terms of SI base units. You know that watt is unit of, first you have to decide that what is the, what this mean. Watt is the unit of, you know that unit of power is watt. Okay. So power is defined as, power is work done per unit time. Yeah, energy per unit time. So work is force time distance divided by time. That is, there are few derived mixture of derived and base units are there. So work is joule per second, but we have to work for base units. Okay, although joule per second is correct unit, but we have to work for base units. So that is kg meter square per second square divided by second. So that is kg m square s minus 3. So kg m square s minus 3. So 39. C is correct option. Which physical quantity would result from calculation in which a potential difference is multiplied by electric charge? If you multiply potential difference times charge, what physical quantity will you get? You know that potential difference is work done per unit charge. So if you multiply this V with Q, you will get work done or energy. So electric energy will be correct option. Stress has the same base unit as stress is force per unit area. So stress and force per unit area will have same unit. We have done that. So 41C. To check calculations, the units are put into following equations together with numbers. Which equations must be incorrect? Okay, so we have to find the equations that is incorrect. Force is joule per meter. You know that energy work is force time distance. So joule, that is Newton meter. So if you make Newton of force as subject, that is joule per meter. Okay. So Newton is force is joule per meter. This is correct. We have to work for incorrect equation. This is correct. Power is joule second. So power is defined as work over our energy per unit time. So power is not joule times second. Okay. So B is incorrect. So for us, it is correct options. Time is meter, this meter will cancel out and this will second will go up. So this is correct option. This time, the unit of time is second and unit of velocity is meter per second. If you bring this, if you simplify these 2s minus 2s1, you will get s minus 1. So this is the unit of velocity. So we had to work for incorrect unit. So the B is answer. 43. Which row of table shows a physical quantity and its correct unit? Okay. Electric field strength is, you know that electric field strength is force per unit charge. So we have to work for SI base units. So force is kg m s minus 2, charge is ampere second. So that is, you have to work for all options. You have to simplify them. kg m s minus 3 a minus 1. So this is the unit of electric field strength, kg m s minus 2 s minus 3. But this is incorrect. We have to find correct unit. So A is incorrect because specific heat capacity is defined as, you know that Q is mc delta T. Delta T is temperature and this Q is thermal energy, that is mc, and C is specific heat capacity. If you make C as subject, this is Q over m time delta T. In Q is energy, that is kg m s minus 2, sorry, that is also meter square, and this is kg, and delta T is in Kelvin, so that will cancel out. So m square s minus 2 k minus 1. This is the unit of specific heat capacity, that is m square s minus 2 k minus 1. So B is also incorrect because the kg should cancel out. So for 43, 43, we have to work for unit of specific heat capacity. This is not unit. Okay. So in first question, let me check again. In first question, this C is in coulomb, and if you sorry, I simplified and I put SI base units, but in this option, this coulomb is not SI base unit. So if I simplify this, this is kg m s minus 2, and coulomb is, you know that I is q by t. So coulomb is ampere second whole power minus 1, that is kg m s minus 2 a minus 1 s minus 1, that is kg m s minus 2 minus 1, that is s minus 3 a minus 1. So this is the same as this. So A is correct. Okay. Sorry, I didn't notice this C. Okay. So electric field strength has this unit kg ms minus 2. This is force, and this is force per coulomb. That is the unit of electric field strength. The product of pressure and volume as the same base unit is, you know that pressure time volume is, if you simplify this, pressure is force over area, and this V is volume. So this is, if you, you know that uh, pressure is, volume is in meter cube and area is in meter square. That will become force time meter cube over meter square. That is force time meter, and force is, you know that force time distance will have, uh, this is force time distance, that is energy. So energy and product of pressure and volume will have same unit. Okay, so in next lecture, I will explain this thing, that how you can find a unit from a given expression. I hope you understood what I have taught you. Thank you so much.